People asked the very first question today. In our tutorial, I will come to the question number 86. Question number 86, right? This question was people in 2014 year combined maths question. Question number 86 in the tute, right? Question number 86 in the tute. Right. Question number 86. Another very good question, people. Right. There you are given. Read question number 86 in the tutorial. Let A, B, C. A, B, C belongs to this notation, people. R. This R is people set of real numbers, right? So we write R like this, and we write another one line here. This is called as the set of real numbers. You know, real numbers in our day-to-day, the numbers we use are called as the real numbers. So then all those real numbers we can put in one set, people. Then that group is called as the set of real numbers. So therefore this A, B, C are three real numbers, means they can be positive, negative, integers, fractions, decimals, finite decimals, and so on. Okay, recurrent decimals and so on, right? Yeah. Okay. And next one given as people and AC product. AC product not equal to 0. Okay, right. People now, next one given, show that 0 is not the root of the equation this. Show that 0 is not. Show that 0 is not a root of the equation this, ax squared plus bx plus c equals 0. Okay, show that 0 is not a root of the equation this. Okay, people, you know, when for example, if I take like this, for example, suppose x squared minus 6x plus 8 equals 0. When I consider, people, this way a quadratic equation, people, we know how to find the roots of this quadratic equation. No? There are three methods basically we learned. What is the first one is factorization method. The second one, complete in the square method. Third one, using that formula x equals minus b plus or minus square root of b squared minus 4 ac divided by 2a. Okay, people, now here very easily we can factorize this, right? You know, no need to explain more here to get the factors, right? Okay, the factors going to be, people, x minus 2 and x minus 4, no? So then you can very clearly understand to find the roots, we have to equate each bracket to 0, no? Then we get, taking this right hand side, x equals 2 or x equals 4. Therefore, the two roots are 2 and 4. Okay, people. So now we found this x value and this x value, so that this left hand side, this quadratic expression become 0. Then people, conversely, as a backward result, when I put this 2 for every x in this left hand side, then when you simplify this left hand side, the left hand side should be equal to right hand side 0. The reason is we found these two x values so that this left hand side equals 0. By equating this left hand side to 0 only, we got these two x values. Then conversely, people, when you put each x value we found, where here, and when you simplify the left hand side, that should be equal to 0. Understand? So now if you need, we can test that. No need to test that one. That is well obvious thing. So now, for example, if I put that x equals 2 here, right, for this x squared, then what do you get? 2 squared minus 6 into 2 plus 8, people. This is 4, here minus 12, here 8. Then 4 plus 8 is 12, minus 12. See here, the simplified answer is equal to right hand side 0. People, like this, when we substitute the root of the quadratic equation for x in that quadratic equation, the left hand side wants to simplify, substitute in the left-hand side simplified answer is equal to right-hand side 0. Okay. This is known as the root satisfies the quadratic equation. The root satisfies the quadratic equation. When you substitute for x in the quadratic equation, and when you simplify the left-hand side, this left-hand side simplified answer is equal to the right-hand side 0. That is called as the root satisfies the quadratic equation. Right, people? Right. Now come to here. Now here you are given, right? Here you are given, people, what? Show that 0 is not a root. Show that 0 is not the root of the equation ax squared plus bx plus c equals 0. That means, people, 0 is not the root of this. That means, people, when we substitute for this x 0 in the left-hand side for this 6 and this 6, and simplifying the left-hand side, we have to prove, since we need to prove that 0 is not the root of this equation, no, then we have to prove when you put x equals 0 in the left-hand side, the resulting statement is not equal to right-hand side 0, is not equal to right-hand side 0. That is what we have to prove. Am I correct? Can you understand, people? We have to prove 0 is not a root of this equation. 0 is not a root of this equation. If 0 is a root of this equation, people, what can you say? When I put 0 here, and when you simplify this left-hand side, right, that left-hand side should be equal to right-hand side 0. The reason, if any root of a quadratic equation, that should satisfy the equation. Now, in this case, people, we need to prove 0 is not a root of this equation. People, when we prove, in this case, now this is new, very new to you. You know how to prove Pythagoras theorem. You know how to prove midpoint theorem. Right, people? In proving the midpoint theorem, people, we write the data, all right? And then to be proved, and if construction available, construction, then the proof. They are the usual way, no, people. That is one way of proving. People, another way we use in our A levels to prove something, that is actually known as contradictory proof. Contradictory proof. Contradictory proof. Contradictory proof, people. Right. Now, this contradictory proof, people, when we explain, really in this case, what we have is this. Suppose we need to prove something, right? Say here, x is a boy, right? Now, suppose this x, right? We have to prove x is a good boy. X is a good boy. Suppose we have to prove x is a good boy, right? In this case, people, data we know, to be proved x is a good boy, no constructions. Now we have to prove. People, now I am going to explain what is the this contradictory proof. X is a good boy, that's what we need to prove. People, under this contradictory proof, right? Under this contradictory proof, we assume, that is an assumption. We assume, people, what we need to prove is x is a good boy. No, the opposite thing we assume. What is to be proved? X is a good boy. That is what we need to prove. But under this contradictory proof, people, we assume exactly opposite thing to be proved as correct. Understand? Then we have to assume, we assume that what, people? X is not good boy. X is not good boy. This way we assume. X is not good boy. This way we assume, people. Understand? What we assume? exactly the opposite thing to be proved. That thing we assume. Understand, people? Now, based on this assumption, we develop some statements regarding this. Then X is not a good boy. If X is not a good boy, then he must sleep long night. X is not like that. If X is not a good boy, he should not wash in the morning, face and everything. No, X is doing that every day. No, not like that. If X is not a good boy, X should not study well, but X works well. If X is not a good boy, he should work in the computer all the day. No, X is not that way. People, even though we assume these things, subject to this assumption, when you develop the statement, every statement people going wrong. Not true. Then finally, people, we get, based on this assumption, when we develop something, people, everything going wrong. Then people, you can very clearly see this assumption should be wrong. This assumption should be wrong. Understand? If the assumption is wrong, people, what is the correct one? X is a good boy. Understand? So that kind of proof is known as, people, contradictory proof. Understood? Contradictory proof. See here, this contradictory proof we use very often in some cases in proving A-level mathematics. Understood, people? So therefore, here, people, we need to prove what? We need to prove what? 0 is not the root of this. Then under this contradictory proof, what we have to assume is, then, people, we have to assume 0 is a root of this. Why? We said what? Exactly the opposite thing to be proved, we are going to assume, people. Understand? So then we'll use, people, the contradictory proof to prove this part. Okay, right now. Then we'll write, people, use of contradictory proof. Use of contradictory proof. Use of contradictory proof. Right. So then we'll write, people. Let's assume that 0 is a root of, let's assume that 0 is a root of the equation ax squared plus bx plus c equals 0. Right? This way we assume. Let's assume that 0 is the root of the equation ax squared plus bx plus c equals 0. Okay? Right. Then write down, then 0 should satisfy this equation You know the meaning, people? Satisfy. Right. That is, put 0 here for every x. Like this. 0 squared is 0. A into 0 is, this is 0. B into 0, 0. Then we get people C. C equals 0. C equals 0. Right. Here C equals 0 we got. Right. Now I multiply both sides by A. Of what? This. C equals 0 now, people. By A I multiply. Then you can see, people. A into C equals A into 0. Both sides of this equation I multiply by A. People, now you can very clearly understand. Whatever this value of A, since this C 0, A into 0, whatever this A, when you multiply this A by this 0, A can be positive value, negative value, any value, whatever it is, people. When it is multiplied by this 0, the product is 0. Then we get A into 0 product 0, AC is 0. AC is 0. We get this result, people, subject to the assumption. But people, look at the given data in the question at the very beginning. AC not equal to 0. But subject to this assumption, people, see here, we got AC equals 0. People, given that AC not equal to 0, therefore, this statement is false or wrong. Then this kind of wrong statement result we got when you go back, this got by this, that got by this, that got by this, that got by this one, that got by this assumption. If this is wrong, people, then this assumption must be wrong. If this assumption must be wrong, if this is wrong, so what is the correct one? We assume what? 0 is a root of the equation this. That is wrong. Then 0 is not the root of this equation that verifies. Understand? We can write this is wrong. This is wrong. Because given that AC not equal to 0. Here, this is wrong because given that AC not equal to 0. Therefore, the assumption is wrong. Therefore, the assumption is wrong. Now we can say, what is the assumption? 0 is a root of the equation. Therefore, assumption wrong means 0 is not the root of the equation. Hence, 0 is not a root of the equation. What, people? Ax squared plus bx plus c equals 0. So people, see here, this is the contradictory proof. This is the contradictory proof. Understand? This is the contradictory proof. Okay, right. This is how we prove it. Right now? Yeah. Right, people, now. Okay, now people will read the next part. What's the next part given? Let alpha and beta be the roots of this equation. This equation roots given as people alpha and beta. Right, okay. Then I can write it like this. Ax squared plus bx plus c equals 0. People, its roots given as alpha beta. You know, when the roots of a quadratic equation are given, We can write sum of the two roots, product of the two roots of the quadratic equation, right? Sum of the roots, people, what? Alpha plus beta. Product of the roots, alpha, beta. People, sum of the roots come in how? Minus x coefficient divided by x squared coefficient. Product of the roots going to be, people, c divided by a. That we have proved on the theories. You can very clearly understand that. Yeah, people, in addition to that, we are given a let lambda equals alpha upon beta. Alpha upon beta, that means when we divide alpha root by the beta, we get it as lambda. Okay, if you write it other way, never mind. Lambda equals alpha by beta, right? Then people, show that something asking to prove AC times lambda plus 1 perfect squared equals b squared lambda. That one we need to prove, people, right? Yeah. So let's see how to prove this one. AC times lambda plus 1 perfect squared. People, this only we need to prove equal to what? B squared lambda. B squared lambda. B squared lambda. Okay. Right. Let's see, people, how to prove this. Right. People, now don't wait till I do everything on the board. I'll tell you the method of getting this answer. Just try. Have you 2 minutes, 2-3 minutes? I'll give you. Right. Yeah. People, now we have to prove this left-hand side statement is equal to right-hand side statement. No, people. Then what we do is this. Can you remember we did the identities in trigonometry? There are also, people, in identities we had to prove the left-hand side is equal to right-hand side. No. What we usually did, people, starting from the left-hand side, keeps simplifying the left-hand side, we got the right-hand side answer available to show. Like that, people, we start from this left-hand side and substitute for this left-hand sides, and we keep simplifying, and finally to the simplified answer we get this. Then we started from left-hand side, finally we could get this right-hand side, this. That says what? This left-hand side is equal to right-hand side. We'll use that method. Therefore, people, this is the method. Right. I'm going to start from the left-hand side. I'm going to start from the left-hand side, right? So in the left-hand side, what do you have is this, no? AC, AC times lambda plus 1 perfect squared. All right. People, now this is what you need to do, right? People, substitute for this lambda. What? Lambda is given as alpha upon beta, no? Alpha upon beta plus 1, right? So this is what you need to do, people, after this. Take common denominator beta within bracket. Then there we get alpha plus beta divided by beta perfect squared. Then alpha plus beta perfect squared divided by beta squared coming. For alpha plus beta here, people, substitute by this. And this beta squared bring before this, right? And think after that how to get this right-hand side answer. Right, now start. I'll give 2-3 minutes. Hurry up, people. Right. Right. Till now, I simplify the right-hand side. AC. Here within bracket, I take the common denominator as beta. Then this 1 becomes beta, no? Alpha plus beta perfect squared. Right now, this is, people, AC. We can square the numerator and we can square the denominator like this. Like this we can write, no? Yeah. People, I write this beta squared under this AC times alpha plus beta perfect squared. Alpha plus beta is, people, minus b by a. Then alpha plus beta perfect squared mean, people, you have to square the right-hand side. We have to square the right-hand side. Once you square the right-hand side, people, the minus will be plus b squared by e squared coming, no? Right. b squared upon a squared coming. Correct now, people? Once you square this left-hand side, there you have to square the right-hand side. Once you square the right-hand side, minus squared is plus b squared by a squared coming. Right. Now you can write here 1a, people. There a squared mean what? A into a. Then 1a, in that a squared, we can cancel down with this a. Then another 1a should remain at the denominator, no, people. Then to remain only 1a, will cancel down this 2. Then our purpose will be fulfilled. Only 1a should remain finally, no, at the denominator. Yeah. Okay. Otherwise, we have to use another step to write this a squared as a into a. And we have to simplify that. Unnecessary people step, no? Right. Okay. Then what I get next is, people, this. Yeah. You can write now this one. Right. Now what do we have is, I write that, people, we are here. I write that we are here. Right. Now equal sign. Okay. C upon a we get, no? C divided by a we get here. C divided by a we get, and this beta squared we have. It is nothing but 1 upon beta squared. And people, this b squared we have. Okay. You know what? This C upon a. What is, people, this C upon a? C upon a equals alpha beta. No? All right. So then for this C upon a, we'll put alpha beta. 1 upon beta squared into b squared. Correct, no? Then, people, as before, 1 beta we can cancel with this beta. Then see what we have. There we have, people, alpha by beta. Alpha divided by beta, and here b squared. In the left hand side, what do you have, people? This, no? Right. But what is this alpha by beta? Alpha by beta is lambda. Right. So therefore we get lambda times b squared to the right hand side. We started from left hand side, people. This left hand side. So then we get, therefore, people, we get AC lambda plus 1 perfect squared equals lambda times b squared. Lambda times b squared. This is how we get that. That one we proved, people. Right. Right. So then if I summarize the things so far we have done, right? We had been given that ax squared plus bx plus c equals 0 equation has the roots alpha beta, and alpha divided by beta given as lambda. Then this data we can write now. So then I summarize that like this. A, B, C are real numbers and AC not equal to 0, subject to this condition that ax squared plus bx plus c equals 0 has the roots, people, alpha beta. Okay. Then we could write alpha plus beta minus b by a, and alpha beta c by a, lambda equals alpha upon beta. Subject to this all data, people, just now we proved this AC times lambda plus 1 perfect squared is equal to lambda b squared. Understand? Right? Then subject to these conditions, right, we proved AC times lambda plus 1 perfect squared is equal to lambda b squared, like this. We proved this. We proved this. Right, people. Now I summarize this way. See here in the question, people, another similar informations given. What are the informations? Right? Yeah. Then people read the third line. PQR, let PQR, see here, PQR are real numbers, and PR product not equal to 0. let gamma and delta be the roots of the equation px squared plus qx plus r. Px squared plus qx plus r equals 0. It is a quadratic equation. Its roots are given as gamma delta. And furthermore, given people mu equals gamma upon delta. All right, now we can write gamma plus delta, mu given as people gamma upon delta. Then gamma plus delta you can write how? Minus q divided by p. Gamma delta product you can write r divided by p. People see here. Instead of a, b, c, we are given p, q, r. Right? And AC product not equal to 0, PR product not equal to 0. And instead of this lambda, given here mu. Gamma upon delta here we have. People, can you see? You can see very close relationship between this set of data and this set of data available. People, you can very easily see this set of data, very easily we can convert to this set of data. How? If I put for this A, simple P, then this will be Px squared. For this B, if we put Q, this is Qx, this is coming. For this C, if we put simple R, this is coming. And for this alpha beta, if we put gamma delta, this same data coming. People, when you compare this set of data and this set of data, they are very similar. They are very similar. Only thing is, for this A, B, C, when you put P, Q, R respectively, and for alpha we put gamma, and for beta we put delta, people, automatically by this we can generate what? This set of data. Then people, since we have proved this kind of relation for this set of data, people, since the same similar set of data here we have, as we proved this way using these steps, for this set of data also, people, we can prove very similar result like this. Only thing is, we have to follow this way. But people, we don't follow that again. Why? People, even though we follow to obtain for this set of data, this kind of result, the same steps in the same way we have to follow. Only thing is, by this itself, we can obtain the corresponding result we finally get for this. We can very easily obtain, people, replace in here A by P, C by R, B by Q. And people, for alpha, we put what? Gamma. For beta, we put delta. Only change of letters available here we have to put. Nothing else. No new simplification steps or no new thing coming there when we take. Then people, since everything is alike, we don't use that this kind of result to obtain for this one, people, following this way. We write similarly as above. We can obtain, write in that way, one sentence. We write for this set of data by observing this result. We write one here. Understand? People, once you observe this left-hand side, AC, that means first and last we have to multiply. Lambda means that given ratio. Then for this equation, first and right we have to multiply PR. Here as lambda, here we have mu. Then P into R within bracket mu plus 1 perfect square equals that said mu should come here. Mu squared means, people, middle perfect square. Then here middle is what? Q squared. Understand? By comparing this result with this result, we can write same result for this set of data. Even at the examination, people, don't do like this the second result to obtain. Why? No point. You won't get marks though you do this way steps. Why? People, only thing is change of letters. Only here we have to what? Change. Understand? So then there is nothing new. The same thing you have done twice. For A-level math students, if he or she does people something, and very similar thing he can easily manage. Therefore, people, no extra marks come in, even though you do like that. You waste your time and effort. So therefore, people, we write similarly as above. We can write by observing this data, this kind of result. Understand, people? Then we'll obtain that too. Right. Write down. Similarly, as above, we can write people, what is the result? What is the result you can write? The result you can write is what? Yeah. AC, first and third. Then here, PR. PR. Right. Within bracket, lambda. Here it's mu. Plus 1 perfect square equals. Lambda means this ratio. Here it is mu. B squared means the middle squared. It is Q squared here. This way, one result we can write, people. This way, one result we can write. Right? Right. Okay. Then we wrote, people. Right. People, now remember, in this question, you are not asked to write this relation. People, by practice, we should understand, if we have this kind of result, we got this one, similar result available in another form, then this result we should be able to write for this one also. That is the, people, the method or the tradition of an examination question. At the moment, you won't get that kind of hints, but people, remember, you are going to examination another 2 years now, after another 2 years now. By this, during these 2 years, people, according to your practice and your what experience, you will really realize this kind of situation, because we do more sums relating to what this examination styles, people. Then, of course, no need to give some hints to get the answer. You will find the path of getting the answer yourself very easily, because at that time when you go to examination, people, you will have done more sums and getting more what experience, and with those things only you go. Therefore, people, no need to say this way to write another what result. At the moment, you might think, how can we get this way? How do we think that we need to take this result? People, at the moment, that kind of issues come into your mind, but ignore them at the moment. That is because of your lack of experience, right? So then they are not issues in the future, right? Okay, people, now then read the next part. Show that lambda equals mu. Oh, lambda equals 1 upon mu holds if and only if ACQ squared equals PRB squared. If and only if ACQ squared equals PRB squared. Now another if and only if proof available there, people. You know, if and only if proof, we have to prove to both directions. Now let's see, people, how to take this answer, the proof if and only if. Right. Now, this result and, people, this result we have obtained. Then I am going to use these two results I obtained. Okay. Then I am going to write it like this. People, I am going to take this result, AC times lambda plus 1 perfect squared equals lambda b squared. I'll take this as number 1, and this one, PR mu plus 1 perfect squared mu times q squared, number 2. Okay. Now I am going to divide this 1 by 2. 1 we divide by 2. We divide 1 by 2. There also you might get an idea. Sir, how do we get this kind of hint to take this answer? That question, if you ask in people, that is because of lack of experience of doing examination style questions, people. At the moment, don't ask like that, people. This is because of lack of experience, right? So then at the moment, just understand and remember, these are the ways. That is the tool, people, for this what issues, right? I divide 1 by 2. Then once I divide 1 by 2, what do we get here? AC lambda plus 1 perfect square divided by PR mu plus 1 perfect squared equals lambda b squared divided by mu q squared. Okay. Now what I do, people, by this mu q squared we multiply to this end, by this we multiply to this end. Okay, and then what do we get? AC q squared mu come in here, lambda plus 1 perfect squared equals what, people? PR comes here, PR b squared, PR b squared lambda mu plus 1 square. This way we get. Understand? This way we get, people. This result we need to proceed the next part of the question, right? Okay. Now this result we have. I'll take this as, people, star. I'll take as star. I'll take this as star, people, right? Now we go for this if and only if proof, right? Right. Now, given that this, people, show that lambda equals mu or lambda equals 1 upon mu holds. Holds means, people, valid, true. If and only if ACQ squared equals PRB squared. All right. Now we'll write like this. Then we start from where, people? ACQ squared equals PRB squared. From there we'll start. Right. Then we write ACQ squared equals PRB squared. Okay. From that we'll start. Right. Because this, if these two are equal, that gives us, that implies, I write this AC q squared mu lambda plus 1 perfect squared equals PRB squared lambda mu plus 1 squared by star. By star. People, now this ACQ squared equals PRB squared means here ACQ squared means this part, PRB squared means this part. This part and this part become equal. That's what this says. Correct, no? This ACQ squared is this, PRB squared is this. Then this says this AC squared and PRB squared being equal. Then you can cancel down this and this because they are equal. Understand? Okay. Then you can cancel here. This way you can cancel down. Then what do we have, people? We have this, no. Then we will remove the bracket, this mu times this one. You can expand by using a plus b squared. What do you get? Lambda squared plus 2 lambda plus 1 equals lambda times mu squared plus 2 mu plus 1. Okay, people? Right. Now we'll simplify this furthermore. Right. mu lambda squared 2 lambda mu plus mu, right hand side, lambda mu squared 2 lambda mu plus lambda. This way we get. People, you can very clearly understand this 2 lambda mu, once you bring to left hand side, that will be minus 2 lambda mu. Then here in the left hand side plus 2 lambda mu, and that minus 2 lambda mu will cancel off. People, no need to bring that to left hand side to show this, they cancel off. We can very easily see that. So then straight away we cancel down that. Now people, I bring the rest terms to what left hand side. Mu lambda squared and minus lambda mu squared, right? I brought this here, and here we have plus mu, and bring this lambda to this side, minus lambda. Now we equal to 0. Now we equal to 0. Right now, people. Right. Now we can take lambda mu product out from this. Take lambda mu common, no? Lambda mu product when you take out, we have lambda here. Lambda mu product when you take out here, minus mu. People, by this 2, I take minus 1 out. You know, when we take minus 1 out, people, inside the bracket, the terms will get opposite in signs, right? Then minus 1 I take out. Then this minus lambda will be plus lambda, plus mu will be minus mu, is equal to 0. Okay, now people, right? Now here we have lambda minus mu, here we have lambda minus mu. Take that lambda minus mu out because it is common. Once you take this lambda minus mu out, here we get lambda mu. Once you take here lambda minus mu out, here we get minus 1 equals 0. Now people, this product equals 0 mean what? This is 0, oh, this is 0, no? Right. Lambda minus mu 0, oh, lambda mu minus 1 equals 0. Then finally you can take what, people? Lambda we can subject, bring this mu to right hand side. Lambda equals mu, oh, people, take this minus 1 to right hand side, that will be plus 1. Then divide both sides by mu. Lambda mu equals 1. Dividing by mu, we get lambda equals 1 upon mu. Lambda equals 1 upon mu. This is what we get, people, finally. Then see here, if this equal to this, we proved lambda equals mu, or lambda equals 1 upon mu. We proved if this two are equal, if this equals to this. If these two are equal, then lambda equals mu, or lambda equals 1 upon mu. If part we have proved. Now people, we have to prove the only if part. That means using this, we have to prove that. Then we know we have to put only the backward arrows. Right now, we have to put the backward arrows like this. Then we have completed but the if and only if proof. Right now, people. Right. That also we completed now. Right. Another part is there. Right. People, now usually in examination question, the question has a smooth flow. That in the sense, people, when we have proved something in the middle of the question or somewhere in the question, people, most of the time that result we obtain by proving, we can use to take the last part, the answer of the last part of the question. Here also this question is a similar question. Therefore, people, it is worth to pay our attention on the result we have proved. Right. So then if I summarize the result available there, people, you can very clearly understand it like this. Now, ax squared plus bx plus c equals 0 quadratic equation has the roots alpha beta. The ratio of the roots alpha upon beta is lambda. Okay, yeah, that is given. Secondly, this equation given, px squared plus qx plus r equals 0 has the roots gamma delta. Then mu equals people gamma upon delta. Right. Now pay your attention on the result we obtain here. Right. What is the result, people? This says, if these two are equal, if this AC Q squared is equal to PR V squared, if these two are equal, this equality implies, okay, if I write that pair here, I write that one here. This implies if these two are equal, what we prove, people? If these two are equal, either lambda equals mu or lambda equals 1 upon mu, right? Lambda equals mu or lambda equals 1 upon mu. Understand? If these two are equals, lambda equals mu or lambda equals 1 upon mu. People, what is lambda equals mu? Here, the ratio of the roots of this equation is lambda. Mu is ratio of the roots of this equation. Then if this AC Q squared is equal to PR B squared, if these two are equal, then this result implies the ratio of the roots of these two equations are equal, or lambda is 1 upon mu. That means one ratio is equal reciprocal of the other ratio. Then we proved backward also, people. What is that? If this or this become true, that implies this. That is our view. If these two are equal, lambda equals mu or lambda equals 1 upon mu. If this becomes true, then ACQ squared equals PR B squared. Understood? That's what we proved. Right now, people? Now read the next part in the question. Read next part of the question, people. Right. You are given what? People, we are given this way. Kx squared minus 3x plus 2 equals 0. Right? And 8x squared plus 6k times x plus 1 equals 0. Right. Two quadratic equations. These two quadratic equations, the roots of the equations, this and this, right, are in the same ratio. What is meant by this same ratio? Same means, people, equal. Same ratio means what, people? Ratio are equal. That's what it means. Now, if I assume has, people, two roots, no? That two roots we can divide one by the other. Ratio means division. Understand? Ratio means usually we write 2:3 as a ratio, no, people? This ratio we can write as a fraction 2 by 3. This is called as a ratio. Now, this is the ratio really. That ratio we can write as a fraction like this. Fraction means people really a ratio. Understand? So therefore, the two roots, if I assume of this equation as alpha beta, I can take alpha divided by beta. That is the ratio. If I take this ratio as lambda, and here the roots assuming of this as gamma delta, and taking the ratio as gamma upon delta, people, what does this statement say? Yeah, the ratio of the roots are the same of these two equations. That means what, people? This alpha upon beta is equal to gamma upon delta. In other words, lambda equals mu. Understand? Lambda equals mu. That's what this part says. People, we proved if lambda and mu being equal, this equality implies here lambda equals mu implies, people, for the two equations ACQ squared equals PRB squared. Then people, I can consider this as my first equation, this as my second equation, this. We have proved if the ratio of the roots of this equation and this equation are equal, then that gives us this equality. Therefore, people, here also this equation and this equation, the ratio of the roots are equal. If they are equal, people, we can write what? This kind of relation for these two equations. Understand? Only thing is, by comparing this equation with this and this equation with this, we have to separately find what are the corresponding ABC values and PQ and R values. Understand? Then we can, people, write. I'm going to compare this equation with this. Then for the place of A, we have K. Then A equals K. For the place of B, what do you have here? -3. For the place of C, what do you have here, people? 2. Right. Now this one I am going to compare with this. For the place of P, we have 8. P equals 8. For the place of Q, people, X coefficient here 6K. Q equals 6 times K. For the place of R, people, we have 1. Okay. Right. Now, when lambda and mu being equal, that implies this equality. Here also now lambda and mu being equal. Therefore, this relation now we can write. Then we can write by the above proof. By the above proof, people, you can write. What is that? ACQ squared. A is K. C is 2, right? Q squared 6K perfect squared should be equal to PR. P is 8, R is 1, PR B squared -3 perfect squared. Right, people? Now you can simplify this. What do you get here? 6 to the power 2 means 36. Into 2 is 72. K squared and K mean, people, K cube equals -3 squared is 9. 9 into 8, 72, people. 72 and 72 you can cancel down, we get 1. K cube equals 1. That says, people, K is 1. Then the answer of K is 1. This is how, people, we take the value of K. Understood? See here, the nice smooth flow available in the question from beginning to end. That is the beauty of the question. This is an examination question in 2014, right? So very, of course, glad of working out this kind of question. Why? One after one, the previous part we can use, and so on we can come to the end of the question. That is the beauty of the question. Right, people? That's how we work out the question. Any question here, people? Any question here? No, right. Okay, then complete this one. Right, people. Then as the next question, we take question number 88. This is also another past paper sum. Take, people, the next question as number 88. Question number 88, right? Question number 88. Right. People, read that question number 88. I'll give you 5 minutes. Hurry up. Yeah, you can, Umar. Okay, people, number 88, it says, this is also a past paper sum. ABC are real numbers such that A not equal to 0 and A plus B plus C not equal to 0, right? Yeah. ABC are real numbers. A, B, C are real numbers such that A not equal to 0 and A plus B plus C not equal to 0. A plus B plus C not equal to 0. And let Fx given. Fx equals ax squared plus bx plus c. Fx is this. Show that 1 is not a root of the equation fx equals 0. Right. Fx equals 0 mean what, people? Fx equals 0 means, what is fx? This, no, right? Ax squared plus bx plus c equals 0. This is the fx equals 0. People, what is asking there? Show that 1 is not a root of the equation fx equals 0. Show that 1 is not a root of the equation fx equals 0. We use what? That contradictory proof. Then what is the assumption? We need to prove 1 is not a root. Then we assume what? 1 is a root of fx equals 0. Right. Then we write like this. Let 1 is a root of the equation fx equals 0. What is fx equals 0? This. One is a root of the equation fx is 0. That means this. If 1 is a root, people, what can you say? 1 should satisfy this equation. Then we can write, we can write A, put 1 for this x, 1 squared plus b into 1 plus c equals 0. 1 squared is 1, a into 1 is a, b into 1 is b plus c equals 0. We get, people, a plus b plus c equals 0. Right. But we are given a plus b plus c not equal 0. Right. Therefore, this is not possible to occur. This is a wrong statement, wrong result. If this is wrong, then the assumption we made is wrong. 1 is not the root of the equation. This. Right. Then we can write this is wrong because given that a plus b plus c not equal to 0. Okay. Not equal to 0. Therefore, 1 is not a root of fx equals 0. 1 is not a root of fx equals 0. Right. That we can take that. Right now, people. Right. Contradictory proof. Right. The contradictory proof is this. Right. Okay. Next part. Let alpha and beta be the roots of fx equals 0. Fx equals 0 means these people now. Right. Up to here, I think you understood. Right. I will erase this. At fx equals 0 mean people, fx is ax squared plus bx plus c. No? Fx equals 0 is this. Its roots are alpha beta. Right. Then you can write people alpha plus beta and alpha beta product. Okay. Right. Alpha plus beta, you can write it minus b upon a. Alpha beta is people c upon a. These two are okay. Right. Now people asking, show that alpha minus 1 times beta minus 1 is equal to this answer. That answer, people, everybody can take very easily, right? Yeah. Right. There, what you need to do is, people, this. We write alpha minus 1 times beta minus 1, people. Right. Now remove the bracket first by this alpha, secondly by this minus 1, and write the right hand side. Then collect the terms alpha plus beta together, alpha beta separately together, and for this alpha plus beta substitute this, alpha beta substitute this, and keep simplifying that, you get this answer. Right. Again, try that, people. I'll give you 2 minutes. Hurry up. Yeah. First multiply by this alpha and this beta, alpha beta. Alpha and this minus 1 minus alpha, minus 1 and beta, minus beta, minus 1 plus 1. All right, people, alpha beta, take this minus sign out, then alpha plus beta plus 1. Right. Substitute for this alpha beta product, c divided by a, minus alpha plus beta, people, minus b by a plus 1. Right. Now we'll take minus minus plus, c divided by a plus b divided by a plus 1. People, here we have 1. No, I'm going to take the common denominator as a. Then here we get this one change, this one change, this one, since the common denominator is a, people, this one becomes a. Then we have c plus b plus a, that is nothing but a plus b plus c. Divided by a. Right now, this one you can write taking this a before and writing it like this 1 upon a. Correct, no, people? Dividing by a mean multiplying by 1 upon a. That you can very clearly understand, people. 4 divided by 2 is same as, people, multiplying 4 by half. Dividing 4 by 2 means it is same as multiplying 4 by half. That's what. Here, dividing by this a mean multiplying by 1 upon a, this part. Correct, no? Right. That answer we got. And now people are asking what? Now asking there, show that quadratic equation with 1 upon alpha minus 1 and 1 upon beta minus 1 as the roots is given by gx equals 0, where gx is this. Right. Now we need to find people what? The quadratic equation with the roots 1 upon alpha minus 1 and 1 upon beta minus 1. Understand? Okay, right. Then I write here alpha minus 1, beta minus 1 is equal to 1 upon a times a plus b plus c. Right. We just prove this one, right? Now, second part. Quadratic equation with the roots 1 upon alpha minus 1 and 1 upon beta minus 1. People, when you are given two roots, and if we need to find the quadratic equation with that given two roots as the roots of that equation, how to write the equation when the two roots are given? Yeah, we learned that people like this, no? X squared minus within first bracket, but sum of the roots times 6 plus next bracket product of the roots equals what? 0. Right. So in this case, people, as our two roots we are given, one root is 1 upon alpha minus 1, the other root is people 1 upon beta minus 1, other two roots. Okay, this theory we discussed. And now we'll substitute. We are here x squared minus sum of the roots means first root is 1 upon alpha minus 1 plus the other one is 1 upon beta minus 1 times 6 plus product of the roots. People, multiply these two. 1 upon alpha minus 1 times 1 upon beta minus 1 is equal to 0. Is equal to 0. Right? Right. Now we'll simplify this little bit. Right. X squared minus, people, within this bracket take this alpha minus 1 beta minus 1 product as the common denominator. Then what do you get when I take this alpha minus 1 and beta minus 1 as the product as the common denominator? You can multiply this 1 by this beta minus 1, this by this alpha minus 1 times 6 plus 1 into 1 people 1, alpha minus 1 into beta minus 1 come in there equals 0. Right. Right. Now, x squared minus here alpha plus beta minus 1 minus 1 minus 2 divided by alpha minus 1 into beta minus 1 times 6 plus 1 upon alpha minus 1 beta minus 1 equals 0 coming. Now people, before going to next simplification, I multiply both sides of this. By this denominator, we multiply. We multiply both sides of this alpha minus 1, beta minus 1 product. Then this one we must write before this x squared. The same thing we must write before this bracket. Then that thing we can cancel down with this thing. This one we must write before this. That and this will cancel off. Right? Then we get alpha minus 1 times beta minus 1 into x squared minus. When I write this thing, people, before this bracket, this and this will cancel off, giving this alpha plus beta minus 2 times 6. And when I write this thing before this and this will cancel off. We get 1 equals 0. Now, people, here, for this alpha minus 1, beta minus 1, earlier we proved no, but this one we can put. Alpha plus beta, people, I can put here minus b by a, we are here, and plus 1 equals 0. Substitute them, people, and simplify. Try to get the answer. Alpha minus 1, beta minus 1 product is 1 upon a plus b plus c, right, this one, x squared, minus alpha plus beta minus b by a, minus 2 times 6 plus 1 equals 0. Right. People, I'm going to do 2 simplifications in one step. It is this. First, I take this minus sign out. Then with this minus sign, here will be plus. Then both this and this become plus b by a plus 2. Meantime, I multiply this equation both sides by people a. Understand? All right. Do that simplification. Then you get this required answer. Then this will be a plus b plus c times x squared. Why? When I write this a before this, a and this a we can cancel down. Right. When we take this minus sign out, people, with this plus sign, it's minus sign, it's plus. Now, by this a, we must multiply inside the bracket. This term we have to multiply, this term we have to multiply. Once I write a here, a and a you can cancel down. This is b. Now this minus sign we have taken out now, people, then this is plus. When you multiply this 2 by that multiply a, that will be plus 2a times 6. And here a equals 0. Right, people, b plus 2a I can write as 2a plus b, no? Right. A plus b plus c times x squared plus 2a plus b times 6 plus c equals 0. This is the equation. Right. This is the quadratic equation, people. This is a quadratic equation. This only, people, in the question, they term as gx. They term as gx. Right? Gx equals 0 means that gx should be this. Right? Therefore, we can determine gx. Right? We can determine gx. Gx is this. Therefore, gx should be, people, this part. Right? No? A plus b plus c times x squared plus 2a plus b times x plus a. This is our gx. Right now? Yes. Yes, our gx. Right. Okay. Right. Another part is there, people. Another part is there. Okay, read the next part. Okay. Now people are given like this. Right. Now we are given this way. A positive. A positive. A plus B plus C also positive given. Right. Now we have fx. Fx is what, people? Ax squared plus bx plus c. Gx, this. A plus b plus c times x squared 2a plus b times x plus a. This. Now people read next part. Show that the minimum value m1 of fx is given by m1 equals this. People, you can see here fx. This is a quadratic function. Usually we write fx in place of y. In place of y. Fx means y, people. Fx is y. If we just write for this fx y equals ax squared plus bx plus c. It is a quadratic function. Then it has a curve, graph. You are given a positive. A means this x squared coefficient. X squared coefficient positive mean, people, the corresponding graph is a minimum graph, a graph like this. If it is a graph like this, people, its minimum value means what? Its minimum value means this height. This height means what, people? Y coordinate of the vertex. Right? Now we have to obtain y coordinate of the vertex of the graph y equals fx. Okay. Right? People, can you remember we did? For example, if I remind these things, we have done this all at the very beginning of this lesson, right? Can you remember when we have one minimum graph like this, y equals x squared plus 2x plus 3, people? Can you remember the way we decided the roots and coordinates at the vertex? We use there, people, the complete n-square method. In complete n-square method, people, we said definitely this x squared, all right? X squared coefficient should be plus 1. Right? Then we can write, people, here. X squared coefficient is plus 1. Then we put perfect squared. And this plus 3. Then within the bracket, what we write? From the x squared without the square, only x, plus divide this x coefficient. It's 2, no? By 2, we get 1. Put that 1 here. And finally, we subtract 1 squared from the end, like this. Then, can you remember, people, we decided the x coordinate of the vertex and y coordinate of the vertex by using this Here 1 squared is 1, 3 minus 1 is 2. People, x coordinate of the vertex we obtain how? By changing this sign to opposite, minus 1. Y coordinate here 2. This y coordinate only people of a minimum graph. Here when we draw a minimum graph, this is the lowest point now people. Then minimum value mean what people? This height. This height mean of the vertex the y coordinate, this one. Then for this fx also people, we need to find what? That way the y coordinate of the vertex. Understood? Then what we do? We have to complete the square on the right hand side. But straight away you can't complete the square because x squared has a coefficient a. Before completing the square, x squared coefficient should be plus 1. Then to make this x squared coefficient as 1, this present simple a, the x squared coefficient, you have to take out from a bracket. Understand? Then people, I'll give you 2 minutes. First try that. Complete the perfect square on the right hand side of this fx. Complete in the square method, right? Yeah. Start people then. Start from here. Right. Hurry up. Right here. Before completing the square on the right hand side, we should have this x squared coefficient 1. But at the moment we have a. In order to make that x squared coefficient as 1, I take this a out from these 3 terms. Once you take a out people, all these 3 terms you should divide by this a. Then when you divide this by a, we get only x squared. When you divide this by a, we get b upon a times x. When you divide this by a, we get c upon a. Okay, right. Now people, this one, we have to complete the square. Right. Then you have to put a bracket like this. It's perfect squared and this c upon a. From this x squared we take without the square only x. X coefficient people b by a, no. X coefficient is b by a. This coefficient should divide by 2 people. B by a should be divided by 2. What do you get there? B by a multiplied by this 2 means 2 by 1, no, half this way. Then we get b divided by 2 way. When you divide b by a by 2, we get b divided by 2 way. Right. Then we said under the completing the square method people, always we subtract the perfect square of this. Always subtract the perfect square of this. Subtract perfect square of this. When you square this, we get b squared. This one for a squared. Right. Now we'll simplify the bracket another little more. Keep this a like this. X plus b upon 2a perfect squared. Right. People, now I am going to take here the common denominator as 4a squared. Right. Here 4a squared, we have this b squared one change. But here we have only a. But our denominator is 4a squared. Then this 4a squared means people 4a into a, no. 4a squared mean 4a into a. Right. In addition to this a, here we have another 4a. By that extra one, we should multiply this numerator. Okay. Then 4ac come in here. Right. Okay. Now people, I am going to do another simplification like this. That simplification is this. From this numerator, I take minus sign out. Then that minus sign coming out with this plus and minus together, minus. Right, people? Minus. Then this order will be b squared coming first with plus sign, b squared minus 4ac. The reason is, people, when you take minus sign out from an expression, inside the bracket, the sign of the terms will change. Meantime, by this a, we multiply this term and this term. Understand? Fine. Then we can write fx equals a times x plus b upon 2a perfect squared. Now I take this minus sign out, then plus and minus minus. That a we keep here, right? This is now b squared minus 4ac divided by 4a squared. People, 1a we can cancel down with this. Then you can write very clearly fx minimum going to be, people, with this minus sign, this whole thing. Understand? Right? Fx minimum. Therefore, you can write fx minimum is equal to minus b squared minus 4ac divided by, people, 4a. Now, we are given a notation. In the question, when you very carefully see, you can get this delta is b squared minus 4ac. This is delta. And for the fx minimum, we are given another notation as m1. So therefore, fx minimum m1. So therefore, we can write, therefore, m1, fx minimum given as m1 equals minus, for this b squared minus 4ac, we are given delta, people. Delta divided by 4a. Right? Now you got that answer too. Understand? Right? Take that, people. Right now? Yeah. Right now? Yeah. People, now we are given another sentence like this. Let m2 be the minimum value of gx. Gx also, people, minimum graph. What is the reason? A plus b plus c is the x squared coefficient. We are given a plus b plus c greater than 0. Greater than 0 means positive, people. Greater than 0 means positive. When x squared coefficient is positive, the corresponding graph is a minimum graph. We know that. Then for this gx also, we have to find what the minimum value given as m2. Then, people, the same procedure we have to use. The same thing. People, if we need to do the same way simplification, people, we said we don't do that. What we do? By observing the previous result and comparing very carefully, we can straight away write one expression. Right? One expression. Okay? Then, people, the minimum value of fx is m1 given by this, no? If fx is this, its minimum value is this. Then gx is this, people. By following this result, write down the minimum value m2 for this gx. I think you can do this. I will 5 minutes. Take, people. Here, this is your fx. When you find this fx minimum, you got this answer. Minus sign available. What is this b squared? X coefficient squared minus 4 times, what is a? X squared coefficient. What is c? This constant term. Divide by, people, 4 times x coefficient. Then when we write gx minimum, people, we have to follow the same way. Gx minimum. What? Minus sign we have to keep here. Right, this one. B squared. B mean, people, x coefficient. In gx, x coefficient is 2a plus b. Then 2a plus b perfect squared. Perfect squared. This one. Right? We have to put the bracket like this. Minus 4. A means x squared coefficient. But in this gx, x squared coefficient is this a plus b plus c. Then for the a, we must write a plus b plus c. Right. And c, this constant term. And in gx, c is this a. Right. And 4 times a. A means, people, x squared coefficient. In gx, x squared coefficient is a plus b plus c. Right, people? You have to think comparatively. But for this gx minimum, you are given m2. This is given as m2 minus. Now, people, you have to simplify this. Right? Simplify this, people. Two a plus b perfect squared. Square of this 2a. 2a squared means 2 squared a squared. It's 4a squared. Plus multiply this 2 and that we multiply again by 2. We get 2ab multiplied by 2, we get 4ab. Then b squared we get. Right. Now this bracket we have to remove. Minus 4a minus 4a squared. And here minus 4ba minus 4ab. And next one, people, minus 4ca minus 4ac. We get this divided by a plus b plus c. Now you can see this 4a squared. You can cancel down with this 4a squared. 4ab minus 4ab. We can cancel down. Then m2 is equal, people, minus, right, b squared minus 4ac. Divided by 4 times a plus b plus c. But you know, people, b squared minus 4ac is delta. Delta. You can put here delta. Then we get m2. Right? m2 is equal to minus delta upon 4 times a plus b plus c. And this is what we get for m2. Right? Now, people, deduce. Deduce means using this result and this result, we have to obtain this answer given. How to take that? Then this is how we take that answer, people. I can subject delta by using cross multiplication to this end and multiply minus sign. That delta answer will put where here. Then, people, we get what the answer asking in the question, right? Yeah. Then you can write, this is okay. Now we can write, but since m1 equals minus delta upon 4a, you can use this as a cross multiplication and multiply both sides by minus sign. Minus 4a m1 equals delta. This gives us delta equals minus 4a m1. Okay. Now we'll substitute that pair here. Now using m2 equals minus delta divided by 4 times a plus b plus c. Substitute for this delta, this answer. What do you get? m2 equals minus delta means people here. This delta is this, no, minus 4 a m1 divided by 4 times a plus b plus c. We get like this. Now people, you can see here clearly, minus and this minus make plus. Then we get plus 4, right? If I write another one more step there, that is not important, write that step there. This 4 and this 4 you can cancel down. By this a plus b plus c, we can use the cross multiplication to this end. Okay, then people will get that answer. What do you get there? A plus b plus c times m2 is equal to am1. This answer we got, am1. Correct, no? Yes. Right. Now, people, the last part. What's that? Hence, show that fx greater than or equal to 0 for all x in R. What is meant by this? X belongs to R. X in R. What is X? X belongs to R. R means what? Set of real numbers. X is real number. For all X in R means what? For all real numbers. When this X takes all real numbers, what we need to prove, people? For all real values of X, that means for all real numbers, right? If and only if gx greater than or equal to 0. Right. People, now this relation we have. Right now I am going to prove that if and only if part. Now people, you have to very carefully understand this a plus b plus c is positive, therefore this gx is a minimum graph. Gx is a minimum graph, right? Now see here, we draw the minimum graph like this. Then the minimum value is this height, no? This height only, people, that we found as m2. This is the gx graph, right? People, you can very clearly understand, if this vertex of the minimum graph gx lies above x-axis, you know, this branch, we can produce this end. Then when you move along the x-axis from negative infinity up to positive infinity, you can see when we walk along the x-axis from negative infinity up to positive infinity, see this way. For all x values, okay? For all x values means, people, this all numbers on the number line available. At any point on the x-axis, when you find the y-coordinate of this graph, that means here, this y-coordinate is positive. That means this gx is positive. Y coordinate means people gx. This height means y coordinate. It is gx. Right? If this graph is lying completely above the x-axis, right? All the y values are positive. All the y values are positive. Right? All the y values are positive for all x values. What is meant by for all x values? When you walk along the x-axis from negative infinity up to positive infinity, we pass one after other real numbers. Understand? At any real number, when you find the y coordinate, if the graph is like this, that y coordinate of the graph is positive. For y coordinates to be positive like these people, definitely the lowest point called as vertex should lie above x-axis. Then gx greater than 0 for all x in R. If what? If this lowest point vertex lies above the x-axis, that means this height become positive, m2 positive, no? When the graph is like this, lowest point is above the x-axis, then this m2 positive. Now people suppose like this, if gx is 0, right? Gx is 0, what can I say? This should come to what? Vertex should come to what? On x-axis, then m2 becomes 0. Then here gx 0. Then if this gx greater than or equal to 0, m2 should be greater than or equal to 0. Am I correct? If m2 positive, gx graph is lying completely above the x-axis. If m2 equals 0, gx graph is like this, equal to 0. Understand? So therefore, people, the condition required for gx greater than or equal to 0 for all real values of x, what is the condition required? m2 greater than or equal to 0. Understand, people? All right. So then we'll write like that. Okay. Then we can write the if and only if proof like this. Right. You can write gx greater than or equal to 0 for all x in R. This statement implies us people what? m2 greater than or equal to 0 for all x in R. Right. Because we obtain one result, right? m2. We obtain the result like this, no? We obtain this result, a plus b plus c times m2 equals am1. No? By this, we can subject m2, taking this right hand side, this way. am1 divided by a plus b plus c, no? Then that m2 only, here we have. Then for this m2, we substitute. This implies what is m2? am1 divided by a plus b plus c greater than or equal to 0 for all x in R. Okay, right. Now, people, you can very clearly understand. This a is positive, given a plus b plus c also positive. People, now suppose here we have 2 times x divided by 3 like this, greater than or equal to 0. That means what, people? When we multiply x by 2 and dividing that by 3, the resulting answer should be positive value or equal to 0. Then, people, what can you say about this x? 2 is positive, 3 is positive. Then when you multiply this 2/3 by this x, for this answer to be positive, definitely this x answer should be positive, no? Otherwise, if this x answer value of x is negative, 2/3 into, suppose x is -2, 2/3 into -2, this answer become negative. Negative means less than 0. Then when this is positive, for this 2/3 x to be positive, people, definitely this x should be positive. Another equal sign. That means 2/3 multiplied by x should be equal to 0. 2/3 multiplied by x should be equal to 0. People, when you multiply this 2/3 by x, if the answer is 0, definitely what is the possibility? X should be 0, no? Then for 2/3 x product to be positive or equal to 0, definitely this implies what? X should be positive. For this to be positive, for this to be equal to 0, x should be equal to 0. Like that, people, here a and a plus b plus c both given as positive. Then once you multiply that by m1, the condition required is, people, should be positive or equal to 0. For this, definitely what can you say? m1 greater than or equal to 0 for all real values of x. Understand? People, what is m1? m1 is the minimum value of the graph fx, right? This lowest point, the y coordinate is m1 of this graph, y equals fx. m1 positive means the graph is completely lying above fx, above x-axis. That means what, people? The fx graph is what? Positive. The lowest point also above the x-axis. Then this says what? fx greater than or equal to 0 for all x in R. That is if proof. Right? Now, only if proof, people, we have to go backward this way. This is how we prove that. Right now? Yes. Right, people? This is how we complete that question.